Hi everyone, it's Miss Berlanga. So this is part 2 of how to do problem sets in physical science. And so what you're going to be doing now is you're going to be working on problem number 2 in that distance and displacement problem set. So remember, it looks like this. And we're going to be working on problem number 2. So problem number 2 talks about Magdalena being at band practice. I'm just going to read over that problem and then we're going to get started. So Magdalena is out on the band practice field going over a marching routine for homecoming. She puts her backpack down. She then marches 20 yards east, 10 yards north, and 20 yards west. Araceli comes out of the band building. She stands next to the backpack and she waves Magdalena over, who then runs to meet her friend. So what you're being asked to do is to provide the total distance that Magdalena traveled, and then you're also asked to give the displacement from where she started, or displacement from the backpack, which is where she started. So let's go ahead and start drawing this out. So just like last time, our first step is to set up a coordinate system. However, notice that this time the movement is up and down, left and right. So we're gonna have to use an XY coordinate system instead of just the number line. So we're gonna go ahead and do that. And I'm gonna draw it kind of big. Doesn't quite need to be this big, but that's okay. And then right about middle, I'm gonna put where my 0 is gonna be, and then I'm gonna go ahead and draw that y-axis. Now, one thing I wanna point out is that whenever you're drawing a two-dimensional problem like this, where there's movement up, down, side to side, you won't necessarily be using the entire coordinate grid. A lot of times we'll just stay over in this corner, or maybe we'll just be over in this corner, right? So what you want to do is you want to just go ahead and draw the whole thing, because you might not know ahead of time where exactly you're going to be moving. Now, if I look at this, I notice that my first movement is east, and then my second movement is north. So east and then north. So I'm going to guess that I'm going to be over here in this corner. First thing I want to do is go ahead and label those points with all the directions. So north is up, south is down, west is to the left, and east is to the right. Okay, so I noticed that Magdalena travels 20 yards east, and she travels 10 yards, then 20 yards west. So I'm gonna guess that the largest number I'm going to need on my coordinate grid is 20. So I'll go a little bit further, a little bit higher than that. I'll go up to 30, okay? So I'm gonna look here at my number line, at my x-axis. I'm going to put 20 right here, put 10 about halfway between 20 and 0, and I'm going to put 30 right there. And then I'm going to do some tick marks and do the 5s in between. So this is 15. This is, oh, excuse me, not 15, that's 5. Excuse me, miss. Then 15. Then 25, okay? And then I'm gonna do the same thing for north. So I'm gonna do this is approximately 10, this is approximately 20, this is 5, this is 15, and this is approximately 25. And now these numbers on the top didn't go quite as far, but don't worry, it's gonna be okay for this problem. And then the others, I'm not going to go ahead and label them right now. And then you'll see here in a second, that's because we're not going to use these other corners, these other quadrants of the coordinate grid. But you can go ahead and do that and put tick marks on yours if you feel more comfortable doing that. Okay, so looking at where she's moving, remember that we usually, unless we're told otherwise, we always want to put our person, that starting position, at the 0. So I'm going to go ahead and put a dot here at the 0, and I'm also going to label that with a couple of things. I'm going to go ahead and draw like a little stick figure, and I'm going to have to draw it off to the side. Magdalena in her hair. I haven't seen her this year, but I've heard it's really long. So we're going to put Magdalena right here, and we're going to go ahead and label that with start, because this is where she started. And I'm going to box that just so it's really obvious this is where she started. Now on these two-dimensional problems, you do not need to put initial and final position down. And the reason for that is because you would have to write down initial and final position for both the x-axis and the y-axis. And that's beyond the scope of ninth grade physical science. If you were an 11th or 12th grader and you were taking physics, then we would do this for both the x and y-axis. But for now, we're going to ignore the initial position. So she starts right there. And then we're told that she marches 20 yards to the east. So I'm going to look over here, 20 yards, and put a dot right there. Now, again, you guys can either do an arc or a straight arrow. For these northeast southwest problems, I find that it's better to do a straight line. And I'm going to do this in another color just so it's a little bit easier for you guys to see. Because you guys use the same color you guys are going to be using your pencil or pen or whatever most of the time, you want to draw your line slightly above the axis, that is fine. That's what I'm going to do. I'm going to draw mine slightly above. And then this is where she ended up. And then remember, every time that we draw an arrow showing movement or a little arc showing movement, we're going to label that with the distance and the direction. So this is 20 yards east. Remember, we put the number and the units and the direction. And then we're told the next time she moves 10 yards north. So we're going to go over here. We're going to look, make sure that we're moving 10 yards up. We're going to put another dot right there. Okay, again, I'm going to draw that arrow. And I'm going to label it 10 yards north. So remember the number and the unit and the direction. Then we're told that she moves 20 yards west. So again, we're going to move in this direction. So she's going to end up back over here on the y-axis. And again, we're going to draw that arrow. And don't worry if everything isn't perfectly straight. That's okay, it happens. And then we're going to label that 20 yards west, okay? So one of the things that we're told here is that Araceli comes out of the band building and she stands next to the backpack. So this is where we need to go back and read at the beginning of our problem. We see that when Magdalena first came out, she put her backpack down and then she marched. So where is her backpack? That's right, her backpack is over here at her starting position. So we want to go ahead and label that. Right, so the backpack is right here. It's at the starting position. So Araceli has come out and she's standing next to the backpack. So you can put the little stick figure right here for Araceli. And remember, Magdalena is over here right now. So Araceli waves her over. She's like, hey, come on, we're going somewhere. And then Magdalena runs and meets her friend. So there's one last movement. And again, I'm going to draw this arrow kind of off to the side and just bear with me because we're kind of running out of space here. And you'll notice that she ends up right back where she started, which means that her last movement was 10 yards to the south. Okay, so this is where we need to look at the stuff that we're being asked to provide. Again, we have drawn our picture, so we want to go back and look at the stuff that we're being asked to provide and see if we've already answered some of those questions. The first question is, what is the total distance that Magdalena traveled? So just like you all have seen from those earlier problems that we worked and those early videos that we've already watched together as a class, all we have to do to get that distance traveled, because again, we only care about the whole journey, we only care about the cumulative number of steps or yards or meters, whatever that unit is. We don't worry about the direction for distance traveled. All we care about is just adding up those little bits of the journey, just the numbers and the units, not the direction. So for part A, the distance traveled, it's just going to be all those little pieces added up, 20 yards plus 10 yards plus 20 yards plus 10 yards. And then I like to do a shortcut whenever I'm adding numbers up in my head, right? 20 plus 10 is 30. 20 plus 10 is also 30. So 30 times 2 is 60. Or you could do it the other way. You could do 20 plus 20 is 40. 10 plus 10 is 20. and then you would have 60. So you can add this up however you want. So the final distance is 60 yards. So that's part A. See, that was easy. For part B, we are asked, what is the total displacement? What is Magdalena's displacement from the backpack? So that's another hint right there that Magdalena and the backpack started at the same place, or that you needed to go back and add the backpack to your picture. And again, you could just write down backpack, or you could have drawn it out, however you wanted to do that. So part B is, what was Magdalena's displacement? Now here, remember, the easiest way to do stuff is the graphical method. So we put our finger wherever we started. But look, she started and ended in the same spot. So what we're gonna have to do, is label finish, because she finished up in the same spot. And then if we notice that, like, oh look, our fingers are in the same spot, we cannot draw an arrow. She ended up right back at the same spot, right? So if she ended up right back in the same spot, her displacement is just going to be 0. So the displacement is 0 yards. And then that's it. Now keep in mind that if Magdalena had ended up in a different spot, so let's say she had just stopped here, her displacement would have been something other than 0. So she literally ended up anywhere else other than right back where she started, it would have been non-zero, right? So if she'd ended up right here, it would have been 10 yards north. If she'd ended up down here, it could have been 10 yards south, right? But since she ended up right back at that backpack, her displacement is 0. All right, folks, let me know if you have any questions. Make sure that you send me that email. And if you did not watch part 1 of this video, make sure that you go back and watch it. So this part was an example of a 2-dimensional problem. Part 1 was an example of a 1-dimensional problem. All right, thanks guys. Have a great day.